In this video, we're going to look at how to find the sum of the following telescoping series. Now, this one is actually pretty difficult. That's why I wanted to record a video. Basically, what we want to do is figure out if there is some kind of pattern to the partial sums. Now, first we'll look at the first partial sum, which is just equal to A1. A1 is the first element. What that means is that we're going to replace n with 1. Okay, so this is, we're going to get cosine 2 divided by what is 1 plus 7? Well, that's 8. And then minus cosine 2 divided by 1 plus 9, which is 10. Okay, now let's look at the second partial sum. So this is A1 plus A2. So now what we do is we're just going to take this guy that we got. Okay, so I'm just going to copy paste that over here. And then the next part is to add A2, which means replace n with 2. So what is that going to be? Well, that's going to be cosine 2 divided by 9 minus cosine 2 divided by 11. So far nothing canceling, but once we look at S3, which is A1 plus A2 plus A3, okay, so whatever I got over here, so that's going to stay. So let's see if I can just copy paste that here. Okay, I'm missing a 2 here, but then I'm going to add cosine, the next one. Now we're replacing 3, right? So this is going to be 2, 3 plus 7, that's 10, minus cosine, then this would be what? 12, right? Because now we're replacing 3 plus 9, that's 12. Okay, now we do see that something is canceling. So this guy will cancel with that guy, right? But we're really going to have 4 left. So cosine 2 over 8 is going to stay. Cosine 2 over 9 is going to stay. So notice how it stayed here, right? It stayed here. Cosine 2 over 9 is that new term. That stays. Well, what about this guy, cosine 2 over 11? Well, let's look at one more. So S4, this is A1 plus A2 plus A3 plus A4. Okay, so what will happen there? Well, all of this, and we are adding another A4, right? So now we're replacing n with 4. So that's 11. And this is going to be 4 plus 9, so that's 13. So now what's happening? So let's see what happens. So first of all, cosine 2 over 11, so that is here, will cancel with that. But no, this actually canceled this one with that one. Okay, but we still have 4 terms left. So let's look at and see what happened. The 2 over 8 and 2 over 9, these two, they did not cancel. And they keep repeating, right? That's just not going to cancel with anything. So these guys are not canceling. So they were just there, right? But there are other 2 terms. So notice how for S2, it was like 10 and 11. For S3, it was 11 and 12. For S4, it was 12 and 13. So we're finally starting to see a pattern. Let's see if we can actually come up with Sn. So for Sn, we will have cosine 2 over 8, because that repeats, plus cosine 2 over 9. That's not changing. And then we have, so for S2 is 10 and 11. For S3 is 11 and 12. For S4 is 12 and 13. Now I think we see a pattern. So this is going to be cosine 2 over. Now, so if it's S2, so look 2, we got a 10 here. So how do we get from 2 to 10? We add 8, right? So this is going to become n plus 8. So for 3, it becomes 11, right? For 4, it becomes 12. Looks like that's right. Okay, so minus cosine. Now, what about this 2 over 11? So for 2, it's 11. How do we get from 2 to 11? Well, we add 9. Okay, so what we've got right now, we've got a formula for the partial sum, and we are going to enter that formula in here. So that's our Sn. The next thing is to find the limit when n approaches infinity of the partial sum. So let's see if we can find the limit of what we just got. So limit as n approaches infinity of whatever this is over Sn, that's the sum of the series. Now, cosine 2 over 8 and cosine 2 over 9 do not change, okay? Because that just does not depend on n. But what happens in here? Well, when n approaches infinity, what you get is 2 divided by infinity plus 8, which is just infinity, okay? And then this is going to be 2 divided by infinity plus 9, which again is infinity. Now, I'm writing a shorthand. What I mean is the limit as n approaches infinity of cosine of this over that, whatever. But this is just a short way of writing it. So this right here will actually turn into 0. So I want you to remember every time you have a number, which is just like 2, 5, whatever, it has to be a number on the top, divided by infinity, you always get 0 in the limit. And what's left are these two terms. They are not going to go anywhere. However, we still have the cosine, right? It wasn't just 0, it was cosine of 0. And unfortunately for you guys, if you did not notice that, you would get this wrong. Because cosine of 0 is actually not 0, that's 1. So my final answer for the limit is going to be cosine 2 over 8 plus cosine 2 over 9 minus 1 and minus another 1 because it's cosine of 0. So it's really minus 2.